Hello, my name is Hassan Amr. I am a physics teacher. This video was produced in the collaboration with the Belize Association of Physics Teachers in an attempt to encourage the online teaching during this crisis. All you need of information about this organization is available on the website apt-lb.net. We are going to explain in this video interference of light, the second chapter in the third unit. First, we want to review some information and introduce some definitions. As we saw, every source of monochromatic light is characterized by its frequency. The frequency nu is measured as a unit in hertz. And since the wavelength is easier to memorize because most of our work is done with visible radiation, the source could be also defined by its wavelength lambda. For example, if we take a red source of wavelength 650 nanometer and a yellow source of 650 nanometer, all these are defined by their wavelength or their frequency if we want. Remember that the yellow is not a single value, it is a set or domain, and the same for red and blue. First definition. Two sources are called synchronous if they emit beams of same wavelength or same frequency or same color. For example, two red of same wavelength are called or same frequency are called synchronous. Second, two synchronous sources. Pay attention here that we are starting with two synchronous sources, which means that they have same frequency, are coherent if they maintain a constant phase difference. The definition and the details of the constant phase difference is not in the scope of our study. We are going only to explain how it is obtained. To ensure that the sources are coherent, they should be produced by the same primary source. Like this one. We take source S, and this source emits light that is split into two sources S1 and S2. Now, what is meant by interference of light? Interference of light is due to the superposition of two synchronous and coherent light beams. How to study the interference? To study the interference, we are going to use a system called Young's double slit. What is the system? This system consists of a source S called the primary that illuminate a slit or screen pierced by two holes, S1 and S2. When the light reaches S1, S2, it spreads. So in this case, S1 and S2 acts as a secondary source. We say that these sources are S1, S2 are synchronous and coherent. To the right here, a simplified diagram of the Young's double slit. Source S, S1, S2, as we saw previously, and a screen E. Before we continue, we are going to review or to know or identify something called optical path because it is useful in our study. Consider that light is traveling between 2 points A and B. The distance that we measure by a ruler between A and B is called the geometrical distance AB. Now, the optical path difference, the optical path AB, is the equivalent path traveled in air during the same duration. Okay, how? In air or vacuum, there is no difference. Optical and geometrical, they are both the same. Therefore, we write optical equal to geometrical. But this has an effect on when we have a medium of index n. In this case, the optical distance AB is equal n times geometrical, and optical equal index times geometrical. For example, here we have 2 points separated by a distance AB in a medium of index n. The equivalent path of this medium or this length is in air AB times n. It becomes longer. If you want to know more details about this optical path, you can solve either the GS session or solve this exercise page 206. Now we are going to study the interference pattern. As we said, Young's double slit is formed of two slits. Here the slits are going to be taken rectangular and illuminated by a primary source. Light undergo diffraction on the secondary sources S1 and S2 and produces the interference pattern. Look carefully on the figure below. Here we have Young's double slit. S is the primary source. The light issued from S falls on this screen pierced by slits. The light diffracts by S1 and covers this region. Similarly, on S2 the light diffracts also, and on the screen we observe this zone of interference which is common to the light that was diffracted by S1 and S2. What do we observe on the screen? We observe a pattern of this form, formed of bright and dark fringes. Therefore, in the screen or in the zone of interference, in the region of interference, we observe in a plane parallel to the plane of slits. And this screen E is parallel to the plane of slits. What do we observe? First, a central bright fringe at O. At O, which is on the perpendicular bisector of S1, S2, the points Si, point of I, S1, S2, and O are collinear, a central bright fringe, and alternate, equidistant, straight, bright, and dark fringe. As shown on the screen, we have bright and dark. With these fringes, as described here, they are alternate, bright, dark, equidistant, of same width or length. They are all straight. Later, we are going to study in detail this pattern. Note, concerning the direction of slits and the fringe obtained. If we look carefully on these two schemas, S0 is the primary source. Here, the secondary source or the slits are placed horizontal. The interference pattern are also obtained horizontal. And if we take two vertical slits, the interference pattern or the fringes are also vertical. Therefore, always, if we have horizontal slit, the pattern is horizontal. Or we say in general, the pattern is always parallel to the direction of slits.